In this video, you're going to get an introduction to integration involving natural logs. So we're going to start off with the natural log rule for integration. So we have u, which is a differentiable function of x. So it's something like a polynomial, a trig function, a radical, something that we've seen before. Right, the antiderivative of 1 over x dx, that's going to be equal to the ln of the absolute value of x plus c. All right, and that's because the derivative of ln x is equal to 1 over x, so the antiderivative of x will be ln x. The reason the absolute value is there is because you cannot take the natural log of a negative number, so this is just making sure that you don't get a negative number inside. All right, so you're going to have absolute values in all of your answers for these problems when you had a 1 over x. All right. The second rule is if we convert it using u substitution, and then we end up with 1 over u du, it'll be very similar. We're going to have ln absolute value of u plus c. It's just depending on whatever u was, we're going to go back and put the x's back in later on. So we'll see lots of examples of both of these. All right, so find each antiderivative. Problem number 1, the antiderivative of 4 over x dx. Well, for starters, I would say pull the 4 out in front. So this is 4 antiderivative of 1 over x dx. So that would be 4 times the antiderivative of 1 over x dx is ln absolute value of x plus c. So this would be the answer for this problem. And that's all you have to do. Number 2 works very similarly, only now we have to pull out both the negative 3 and the 7 in order to get that 1 over x dx that we're looking for. So this is equal to negative 3 over 7, antiderivative of 1 over x dx, or negative 3 over 7. The antiderivative is actually natural log of the absolute value of x plus c. So there's our answer for that problem. Okay. So those two are fairly basic. If you see a number over x or maybe a fraction with an x in the denominator, then you can go ahead and pull the fraction or the number out in front and then use the natural log rule for an antiderivative. Okay. Let's take a look at some substitution problems that will include natural logs. So in this problem, we're going to use u is equal to the denominator, and we're going to use u is equal to the denominator because it has the bigger degree. So we're going to use u equals x squared plus 5x minus 3. If we do that, what would du be equal to? So the derivative of that is 2x plus 5 all times dx. Now if we look back at the original problem, what I'm circling right now is going to get replaced with a u. What I'm circling up top, we have to replace based off of this. But they're not quite identical. Actually, we're going to replace the dx as well. So in order to go through and do this, I need to figure out how can I make 2x plus 5 become 6x plus 15. Well, if I take that expression and triple it, if I do 3 du, wouldn't that give me 6x plus 15? So that's what we're going to end up doing. So here's what the rewrite looks like. The 3 du takes the place of the circled 6x plus 15 in dx. So we're going to have a 3, whoops, we're going to have a 3, an integral sign, and a du. So that replaced what was circled in red. And now what's circled in blue was a u, but it's in the denominator of a fraction. So I'm going to make that 1 over u. And now this is a natural log. So this will be 3 ln absolute value of u plus c. But what I need to go through and do now is I need to replace the u. I have to put it back in terms of x. So our final answer for this problem is going to be 3 natural log absolute value of x squared plus 5x minus 3 plus c. All right, so this is our final answer. We could use properties of logs to bring the 3 back up inside as an exponent, but it's not really necessary, so we're going to just leave it the way that it is. Okay, moving on. Example number 4. Again, we're going to try substitution, and the indicator for substitution here is because I have two polynomials, one is degree 1, the other is degree 2. Since they only have a difference in degree of 1, that's what tells me that I should try substitution with this. All right, so what would u be in this problem? Well, once again, it needs to be the term with the bigger exponent. So I'm going to go with the x squared minus 6. What does that make du? Well, that makes it 2x dx. And don't forget, when you're finding du, you really need to write dx, otherwise you technically can't replace it up above. Now, we almost have 2x dx. We have that negative sign out in front, so I'm going to make this negative du is equal to negative 2x dx. Or you could pull the negative out in front and then just replace the 2x dx. Okay, so the rewrite on this guy, we're going to have a negative and a du, and that replaces the negative 2x dx. And then we have x squared minus 6 is u in the denominator, so this is again 1 over u. So the antiderivative of that is negative natural log absolute value of u plus c. And then we replace the u with the x squared minus 6 to get negative natural log absolute value of x squared minus 6 plus c. And once again, I could go through and bring that negative sign, make it a negative 1, and bring in as an exponent, but we're not going to be condensing these expressions at all. All right, one more. Let's take a look at this one. Now, this problem has an actual natural log in it, and we don't know how to find the antiderivative of natural log. That's something that we don't know how to do. So the only thing I can do is try u is equal to the ln of x and hope that it'll work out. So let's see how this pans out. What is the derivative of ln x? Well, the derivative of ln x is 1 over x. Tack on the dx. And we pretty much have that going on here. If you take a look at the original function, I'm going to pull that 10 out in front. And then we can say that this is the natural log of x times 1 over x, and then a dx. We can split that apart if we want to. If you multiplied all of this back together, you'd get back to 10 ln x over x. So this is going to work out quite nicely because this right here, du, will be equal to this part over here. And then this will just be u. So our rewrite on this guy is 10 antiderivative u du, which will not have the natural log antiderivative. How do you find the antiderivative of u? Well, you add 1 to the exponent and divide by the new exponent. We keep the 10 out in front, so it's 10 times this, and tack on our plus c. So 10 divided by 2 gives me 5, so this is really 5u squared plus c. But then u was equal to the natural log of x, so our final answer will be 5 quantity ln x squared plus c. And that's our final answer. We don't need the absolute value symbol in this problem around the x inside the natural log because when we were finding the antiderivative, we weren't using a log rule to find the antiderivative. The reason there's a log in the answer is because u was equal to the log. All right, so hopefully this is clear. If you have any questions, let me know.